Hello everyone, this is part 7 of the 3D printed animatronic creature, and I'm wanting to show you today on me building the so-called or design the gimbal cover or gimbal base bust or housing. This is what's going to be holding the so-called the turn mechanism for the gimbal and or hold the entire gimbal in place so we can cover it with a chest skin and a chest plate. So I'm going to show you all the whole process here. In Decimation Master and ZBrush, I was able to reduce the polygons. But then also what I do is after I do that, I bring it into uh, ZBrush or the Z remesher, and that way it'll clean up the polygroups as you see here. And I'll still want to reduce it. I don't want it too large. Try to keep it under 2 megs if I can. But this is what I have. But still, I have to make sure everything is kind of, centered. I mean, that's the key to this whole thing. And and at the final design of this, now what I'm going to be doing is making, once again, the bust enclosure, I guess it would be, that holds the gimbal in place and covers it so you can put skin over it. But in that skin area where that plate is, it's going to be glued. But what I did here, I made a copy of the chin and neck area or the chest piece, what we're going to be using. So I want to just cut away this chin area and just do a slice cut of this whole chin area. Now, later on, this thing that I'm designing here is mainly for when the animatronic's finished. But it's going to have, there's going to be there's going to be two more of these. One is going to be for the sculpture, and an exact duplicate of that one's going to be for the core. And y'all have not seen the core yet. Now, that creature being low poly is probably the closest to the core that we're going to see this early in the process. But it's going to be mainly the more of the shape of the animatronic than you see the creature. But it's going to be blocked out. But this whole base is going to have it's going to have mold keys in it, and this is the critical part of the whole thing because when you mold the creature in silicone and them keys are copied into the silicone, and then when you take your core, the core will fit into those keys. So now you have a space generated through in the mold. So when we put the silicone in there for the skin, it will make the skin. But here's where I started designing this so-called, I guess, the chest plate. And as you notice that I had reduced the size of this thing so skin will lay on top of it. Now this will be a 3D printed piece later just so we can put the skin on it. And the skin on the very, border of this whole skin area will be the only thing attached to it. Everything else will be moving freely. It's just to keep that skin stationary when the head turns left, right, up, and down. So, but you notice the size of it being somewhat smaller, so we can go ahead and just generate the skin for the later process, like I just mentioned earlier. But now this is kind of the enclosure part of it. And all this is going to have to be modeled, edited. All this underneath this will be removed, and it'll be like a shell of this so-called chest piece on the inside, and all smooth and stuff like that. So, there's clearances, and there's also going to be an access panel. I did make one for the back. I mean, for the bottom of it. But there's going to be one in the back also, so we can, make any kind of adjustments and things like that. And if we're going to have a servo controller, it's just the location of that. But and like this, the servo block has screw points, and I have to design all that kind of a carriage. I mean, you could even put another servo in there to move the gimbal back and forth to make it where the whole neck moves forward and back, like in a like a seesaw method. But here I'm just kind of basically forming this so-called area around this chest piece so we can and I have to have clearance for these servos, and you'll see later what I had to do from what y'all seen from the last video, what changes that I've had to make. Here what I'm doing, I'm just kind of modeling an area so I'll have room for the servo block to rotate, but it's up a little high, and you'll see that later where it's going to be placed at. Because the higher the gimbal, the the shorter the linkages from those servos to do the tilt mechanism. But it's just a simple design. This plate right here is just going to be an access panel to where I can work on anything. But I can't. I mean, I could probably pull the gimbal straight from this box, but I'd have to make sure that I have access to all my screw points to the so-called servo block. But this is a lot of planning for this animatronic. To achieve this realistic movement, it's just a lot of designing and planning, and you test, and if something don't move right, you have to redo it. But you see here, and this is what I've gotten so far, and this is what it would be like. But you see my servo horns are sticking up or sticking out of the skin, so now I know that it's not enough room. So now I got to make adjustments, and this is how I made the adjustments. So what I do here is I'm going to bring up the gimbal, and you'll see where the servos are. And the servos show those so-called servo arms, and that controls the linkages. Well, if they're sticking out there, so I got to manipulate this. So what I'm going to do is I'm going to invert these so they're up, and I'll be able to mount them on this aluminum beam, and I'm just trying to work out all the problems. And you see now I've generated some area to work with, and these servos are small, but they're end to end. So, but I mean, they are considered micro servos, but they're on the wide side, and they're heavy. They'll lift heavy torque. So what I'm going to do here is I'm going to remove that so-called spin table because I won't need it. Like, once again, I'm just going to mount it on this beam. But what I'm going to do is, instead of having a 9-hole aluminum beam, I'm going to go with a 7-hole aluminum bead. So I put this circle, this called cylinder around this. This way I can see some kind of clearance area, as you see here. This will, when this rotates, this will show me clearances that I have for these, because these servos will be spinning, and I mean, they have to be there, and they have to spin with it. You can't put them separate, as you see here, but it's still too large. So I got to the point where, to save even more space, we're going to design another servo. So I'm just going to eliminate all the headache and worry or try to figure out that. So I went on to King Max again, and I got a schematic of another wing servo, but these so-called screw points are horizontal instead of vertical. So that way they're thin, and they're pretty strong. And I just did the research, and I searched through a few of their wing servos, and I found one that had a pretty decent torque. but not a whole lot of torque. It don't need to be, lifting 40 pounds. It only needs to be lifted maybe a pound. And that's overkill because this thing is small. But you got to realize that I will be lifting or rotating uh, about 8 servos in the head and plus the skin. So what I'm going to do is I'm just going to go by this schematic right here and I'm going to draw out this servo and get it all, just a quick, easy reference. And it's accurate because I'm just following the schematic measurements. Now, I like servos a lot, and animatronics, and it's a passion. And I go in there and I search and do research for the servos and which one to use. But everything is a measurement, and by having a library of these servos, you can know what sizes to use. And like, it's a perfect demonstration of what we're dealing with now. The servos that I had in there, and I couldn't put them, any other way. It's just that way. But I'm going to show you what I did with these servos, and I think you're going to like it. So after I design the servo, I'm going to make a servo block. But I'm going to do this setup a little bit different than the other one. Instead of being bottom to bottom, I'm going to put them, because this is half the thickness of the other servos. I'm going to invert one and have the other one the other way. So that way I have left, right, and they're sandwiched together. But you'll see how much space I've saved already. And this will narrow the so-called linkage area. And I'll just place this on that same beam. And I may lower the beam back down to a 9, but we're going to see, and I'm going to demonstrate it. Here I'll just copy a horn off, a servo horn off this other one, and I'll just place it right here onto this servo, because these horns match the same size. Now, on the schematic, you'll see 90, I would say 99% of the servo schematics that they have out there, you'll very rarely see one with the horns on the servo or design, the schematic itself. And I wish they would do that, because you need to know the height of the servo horn that's on the servo, because that will give you the correct measurement where your linkage is going to be. And see, I don't really truly know that until I put that screw inside that servo and mount that servo horn and measure it with a caliper. But once again, it's one of them things is, I guess, I should have done this first, and then that way I wouldn't have had any kind of problem. But you see the clearances I have. Now, it's not going to be moving, 180, this creature's not. It's just going to be, maybe a 70 millimeter, 70 degree, but I think this is going to work well. What do y'all think? Now we're going to take a look at X-ray, and you can see how everything's going to be mounted, and you see this the servo block on the bottom there. And then this way I can kind of work things out, and where I can maybe location for the the servo controller, where it will need to be located, kind of design the so-called openings, and to where I can have everything laid out correct. And then, but as you see here, you can see a good profile look, but it turned out well. But I'm happy with this. This is the start of having the thing, it's getting close to where I can start doing finalization on all these parts. But it's coming along. I'm going to pop this skin on, and then I'm going to remove the skin again and make an STL file of the animatronic. And then I'm going to import it into ZBrush, and we're going to put the skin on this, and we're going to do some studies to see how it's going to look with the skin on and see it in an x-ray version. So what do y'all think? Let me know in the comments. If you like the video, leave likes and comments and share, and I hope y'all like what I'm doing. You know, it's fun. This whole video right here was 2.5 hours of recorded work, but you know it's what I like doing, and we'll get this animatronic up and running with skin on, and it's just fun. And I want y'all to be part of it. As of right now, I'm looking at it, the numbers right now, I have 6,670 subscribers, and thank you so much. And thank you for the thumbs up and likes and the sharing, and I appreciate y'all, and I'm glad y'all have an interest in my animatronic creature here. And this has been 3D printed animatronic creature part 7, and this is what we have, and this is what we're going to be making, and I'm going to be setting up Patreon, and when y'all share these things and comment and likes, it helps this channel to generate some kind of revenue for me to support the content that I'm doing. But we're going to have the Patreon set up, and we'll have files, and y'all be able to build it and make it move. Y'all have a great day. Thank y'all again. Later.